Good afternoon, everyone, and welcome to this session called Spotlight on Green Hydrogen Developments in Denmark. My name is Emilie Mørup. I'm the organizer of the Danish Pavilion at A51 by the front entrance. We hope you will visit us later today if you haven't already stopped by. Now it's my honor to be the moderator of this discussion and presentations of 4 of our 13 companies at the Danish Pavilion. First, we have Sandor Schrameyer from Ørsted, who is the senior project manager for hydrogen, and he has developed the project portfolio in the Netherlands. Also, he has previous experience with project management in oil and gas. Secondly, we have Ravn Nielsen from Rambøll. She's the chief advisor for Power to X. And also, she was actually one of the nominees for Hydrogen Person of the Year 2 days ago. She has 12 years of experience with hydrogen and electrolysis. Helge, Vandel, Jensen, the third person in the row, is from Danfoss and Global Business Development Director for Power to X. He has 30 years of experience with business development in Danfoss, and the last 5 years he has been the Development Director for Power to X. Last but not least, we have Hassan Modarresi. He is Head of Section and Technical Director of Clean Fields Projects in North America. Hassan has 20 years of experience with ammonia, methanol, and hydrogen industry. And they are happy to share their experiences with you today with some presentations followed by a Q&A at the end. So please think of questions to ask these 4 hydrogen pioneers following their presentations. Thank you. Sandor, the floor is yours.
Okay. Good afternoon, everybody. I would like to tell you a little bit about Ørsted and what we do in P2X. And, can I have the clicker? Here we go. Yes, thank you. I would like to share with you an overview of what Ørsted does in P2X. It's a relatively new business in P2X. We started this journey about 3 or 4 years ago. And what I would like to do is show to you what we've been doing in those couple of years and where we are today in that journey. But first and foremost, Ørsted is very much a company that our vision is that we want to create an energy that a company and a world that runs entirely on green energy. And we see P2X very much a core part of that business. Traditionally, it has been very much in wind farm development, and now slowly but surely we're moving into the P2X space as well. And these are some of the areas that Ørsted is very active in. I think most of you will know Ørsted as a company very large in offshore wind developments. More and more we're getting into the onshore wind business, bioenergy, and then lastly the renewable hydrogen and green fuels, which we collectively call P2X. So this is our vision of a future energy system. It is an integrated combination of wind parks, energy islands, and the electrons from the wind farms are used to then subsequently produce green hydrogen through electrolysis. And then the hydrogen we can either sell as a hydrogen project to industrial off-takers, or alternatively, where the P2X comes in, is we actually produce green ammonia, green methanol for the shipping industry, for example, or green transportation fuels. And these are the kinds of projects that we are now working very hard to develop. Now, to move specifically into P2X, I wanted to give you a bit of an overview of our portfolio of projects. And what you can see here is that we started off largely in Western Europe, Netherlands, Germany, Denmark, Sweden, but now we're also slowly but surely moving into the United States. And this gives you a snapshot of our project portfolio that we're presently developing and maturing. We have a couple of projects in the Netherlands, and I'll show you 1 or 2 slides on that in a minute. Likewise, in Denmark, we've taken the investment decision on our first project in Sweden, and I'll tell you a little bit about that. And in addition, we have projects in Germany and the United Kingdom. And slowly but surely, we're also moving into the US, primarily as a result of the Inflation Reduction Act, which has provided a real opportunity to move forward with some of these projects. Yeah. Now, specifically in the Netherlands, these are the projects that I'm working on and responsible for. we have a group of projects which we call CH to Land. And what we're trying to do here is utilize the electricity that is coming from our own Borssele wind farms, Borssele 1 and 2 wind farms. And we would like to use part of that electricity to convert that through electrolysis into green hydrogen, and then sell that to companies initially within the Netherlands that are all connected to the hydrogen backbone, so that we can help to decarbonize the heavy industry initially in the region of Zeeland. But as that hydrogen backbone further develops throughout the country and even into Europe, we would also like to start looking for industrial customers to decarbonize their facilities across the country. But our focus now is primarily in the region of Zeeland, where there's actually a very large base of industrial companies with very high hydrogen requirements. And that's where we would like to support this industrial decarbonization. Yeah? Now, we've started to develop these projects on a specific piece of land, and we're now working on a number of feasibility and conceptual studies to mature this site as we progress with initially a number of smaller projects, and then in the next 3, 4, 5, 6 years, we would very much like to grow that portfolio of projects, ultimately leading up to gigawatts of electrolyzer capacity, so that we can serve the industry as the demand of the industrial players starts to grow. And this is an artist's impression of what such a development could look like. We have, in the back end, you can see a number of electrolyzer facilities. Of course, a significant part of the area is required for the electricity to come in with large switchgear areas, because the amounts of electricity are quite large that these facilities would consume. And this is what we're now developing and ready to move into the next phase in the next couple of months. Then we are also very active in Denmark, which shouldn't come as a surprise, Ørsted being a Danish company. And this is an example of a project which we called Green Fuels for Denmark, which is co-located with a bioenergy power station. This is just outside of Copenhagen. And what we're doing here is similarly try to develop a number of electrolyzer projects. But because of the CO2 emissions from this power station, we try to capture that CO2, biogenic CO2, and then utilize that for the subsequent production of methanol together with the renewable hydrogen. So here's the benefit of not only using a waste product from a power station in addition to the electrolysis, so that we can not only decarbonize avoid grey hydrogen production, but also actually take the CO2 emissions from this power station and convert that into a green product. And similarly, we have an artist's impression. So you can see here the outlines of the power station. And on that same site, we are now trying to integrate these electrolyzer facilities with the methanol facilities as one large green facility to provide and manufacture green end products, in this case in the form of methanol. And then lastly, I should say, we have a project in Sweden. This project has actually taken an investment decision, so this is really happening. This is a green methanol facility again in the northern part of Sweden. I find it difficult to pronounce the name, but believe me, it's real. This is a photograph again of a biogenic bioenergy power station. And again, similar to the photograph I showed you a minute ago, what we plan to do here is develop electrolyzer capacity with a methanol plant at the back end to serve the shipping industry along the coast of Sweden and the Baltic Sea. And this is what it could look like. And that was what I wanted to say. And the flagship one is actually the subject of the next presentation. So I'd like to hand over to Eva.
Thanks a lot.
Thank you very much. There you go.
Thanks. And I'm very pleased to be able to share with you a few more insights to this flagship one project of Ørsted that we from Rambøll is assisting making this project come true. So my talk is bringing Power to X projects to life. Rambøll is an engineering consultancy and helping very much on renewable and sustainable projects. So this flagship one is the largest green methanol plant that will be realized already in 2 weeks' time. There's the groundbreaking event. So you are indeed right, Sandor. This is not only plans on paper. now we start actually realizing the Power-to-X and green hydrogen projects. So 55,000 tons of methanol per year from CO2, biogenic CO2 captured from that biomass-fired plant. Hydrogen from electrolyzers, 70 megawatt of electrolysis is combined then into methanol with methanol synthesis. What Rambøll is assisting Ørsted with is first in the development phase. We have been reviewing the engineering design and safety design. We have assisted with market screening for who can be the providers for construction and installation contractors. And now we are into the execution phase, where we do safety design, we do workshops, we do layouts, 2D and 3D, so how is this actually going to be made physically, 2D and 3D. I will show you a bit about our results. Civil work design is a surprisingly big part of Power-to-X projects. We focus very much on the electrolyzer and also a bit on the synthesis that might come after. But having all the surroundings in place and the logistics, permitting, all these, and civil takes a lot of time. Furthermore, we will assist with the purchasing process and tendering process for this project. My illustration is a typical project flow, and yeah, even though hydrogen can be used as a rocket fuel, it's not rocket science, so this is not much different from many other construction projects. We work from the very early ideas, if our partners involve us in this that moment in time, to qualify, to make market research, site selections, funding support, and then we go on to the pre-feasibility and the basic design, detailed design, and can take the projects through this construction management until we are in operation. So this is a photo of the flagship 1 site in Örnsköldsvik, I think. I'm also not Swedish. If we zoom in a bit, this is another season of the year, but you can see how there's this power stack, there's transportation or conveyor belts, and what might look like a parking spot in the middle is where the new plant for methanol production will be made. When we then start seeing how will that actually look like, the blue parts here illustrated is what we have already in the site in this location, and then the other colors represent what is being built from now on. Then we zoom in a bit more, and this is then as a peek into how is such a plant actually designed in more detail, heights, spaces, where will pipes go, etc. And from this, and then detailed design, then construction starts taking place, and with a groundbreaking event in only 2 weeks, it's really good to see this come to life. A few other examples of the 130 projects that we from Rambøll have been completed, been doing on hydrogen and electrofuels over the last 3 years. Ideas, due diligence, checking the technology and soundness of projects. Concept developments, pre-feasibility studies. We are looking into water for Power-to-X. We have sustainable solutions so that the water resource will not become a problem when we are needing this for the Power-to-X and for the electrolysis. We have been doing technical due diligence on solid oxide electrolyzers and ammonia. We are helping with funding, EU Innovation Fund latest for a hydrogen plant, large scale. And we do feasibility studies I must admit, even though we are really, really happy over the last 12 months that more and more projects have come into the actually realization phase, there is still the majority in that earlier feasibility before the final investment decision. There we have made concepts for offshore hydrogen production, hydrogen plants, various sizes, and hydrogen refilling stations. The ones that have taken the next step is the flagship one for Ørsted, 1 gigawatt hydrogen plant in Esbjerg in Denmark, 2 megawatt hydrogen plant in operation. They have been producing the first hydrogen. That's very, very great milestone. And then also production of green methane, so synthetic natural gas, important project for us in Finland. Rambøll is an independent engineering, architecture, and consultancy company. We have 17,000 experts, and we have a strong presence in Northern Europe. We are owned by a foundation, so we are really independent and do our utmost to give the best solution for our partners, for our clients. You can find my colleague Anders and myself at the Danish booth afterwards. Thank you for your attention. I'm handing you on to you.
Good afternoon, ladies and gentlemen. My name is Helge Jensen. I'm Business Development Director at Danfoss. Danfoss is a family-owned business. We are about 40,000 colleagues around the world, all active within energy savings, electrification, and also moving into the green transition. And I'm here to talk about some of the components and solutions that we offer into electrolysis and Power-to-X in order to reduce the cost of green hydrogen and also to improve efficiency in general. So the role of Danfoss here is not to produce complete machines. We are here to be a sub-supplier of components and technology that can optimize the efficiency. And in this, say, theoretical electrolysis plant that we have shown here, we offer heat exchangers that goes into the electrolyzers themselves. We also offer high-pressure pumps, for instance, for water treatment systems, for the water for the electrolysis. We do oil-free heat pump compressors for heat recovery systems, for instance, for district heating systems. We do pressure and temperature sensors, motor drives, but probably in terms of value and importance, the most important product that we offer to this is the AC to DC power converters that powers the electrolyzers. So this is sort of the short overview that we have in our range, and obviously ranges from very important but small components to something in the size of a 20 or 40 foot container. If we look at the technology for the power conversion, and there's also been other speakers here today talking about power conversion, we believe that it's important that the power supply for the electrolyzer is providing a clean DC without too much ripple and too much harmonics going on top of the DC. So basically a perfectly clean DC. Also what's important is that the connection to the grid is as smooth and easy as possible. So we offer IGBT-based active converter solutions that basically produce, if not no harmonics, and at least a very low harmonic footprint on the grid. So in this kind of installations, typically less than 3% harmonics. The overall efficiency is also important, and these solutions have typically better than 98% efficiency at the running load. The power factor, for those of you who are electrically oriented, is important because in order to get the connection to the grids, if we talk about bigger systems, you have to have both the harmonics under control. You need to have a unity power factor or even an adjustable power factor. And you also need to be able to come up with simulation data that shows that the total solution is suitable to be connected to the grid. And a few years ago, when we started talking about these solutions, nobody was interested in sort of the grid connection, because if you just connect 1 megawatt to the grid, who cares? But if we now talk about hundreds of megawatts, 200 megawatt, 1 gigawatt plants being connected to the 400 kV grid going through Europe, that means you have to be really sure what happens, how the converters, how the system is behaving if there are any malfunctions on the grid. You don't want to lose 1 gigawatt of load on the grid if there's a short dip, for instance. And here we have seen that the grid simulations, having the right data that can be provided to the EPCs, to the grid companies, the TSOs, is super important. All the projects come in different sizes and shapes. Sometimes we need to provide outdoor solutions like containerized solution, and sometimes it's an indoor solution that can be built into a larger plant. For us, it doesn't really matter. We have solutions that can be put into the solutions as required by the client. Now, the solutions that we build it on is standard products. So we very much believe in standardization, modularization. So everything we do here is based on something we produce in very big numbers also for other applications. Maybe the software is adapted to this, but the general hardware, the functionality is exactly the same as we use for other industries. If we look at an example here about a large electrolyzer plant, and let's assume it's connected to the 400 kV grid. So it's grid connected. There's, I'm sure, a lot of wind, a lot of solar also being fed into the system. And if the electrolyzer plant is going to be connected to the grid, it's very important that the connection is so stable that the transmission system operator doesn't get any trouble if there's any dips or any malfunctions in the grid. So some of the things we have been simulating recently is what happens if you have a short dip, maybe 100 milliseconds on the grid. How can we make sure that we are staying connected, and also that we can keep the same load on the grid also after a few seconds? And here we have created some simulation tools also for the converter, where we can also include the data for the electrolyzer and the data for the transformer and the grid, in order to prove that the system is stable and has a good efficiency. And the solutions that we provide here, which is shown here as the red box with a Danfoss name on it, is basically a solution that can be connected to the grid without any external compensation devices like STATCOM filters or harmonic filters. It's basically scalable. It can be connected to the grid, and you can add as much load as the system is designed for. So stability, efficiency, and stable performance is the key. So that was my short presentation, and happy to answer any questions that come later, and we can meet at the Danish Pavilion later. So thanks.
Thanks, Helge. Thank you. Good afternoon, everybody. My name is Hassan. I'm going to talk about the financial modeling tools that we have developed, and I would like to start with just a background picture here. It's a visualization of a project called Megaton in west of Denmark. It receives 4 gigawatt of electricity, renewable electricity, and it is around 100,000 tons of CO2, biogenic CO2, and produces around 1 million tons of mixed products of ammonia, hydrogen, and methanol. So one question that everybody would ask that who has decided about this size, the capacities of different parts of the plant? This is a kind of complicated infrastructure, even though each part is kind of by itself is a mature technology, but integrating and bringing everything together and also operating in a dynamic operation it's a big challenge. So hopefully we'll be able to answer that question. Before just diving into the presentation, I would like to introduce our company. We are an engineering consulting company with over 90 years of experience. And our playing ground is mainly the Northern Europe and North America, UK. Our backbone business are in the sustainable energy, large infrastructure, large buildings, and climate adaptations and water. So I'm a part of sustainable energy, where we are looking at the Power-to-X projects, carbon captures, and offshore wind. We are around 7,500 people around the world there, and we have done almost over 100 Power-to-X small projects and also the pre-field studies in the last couple of years. So let me just start with the importance of the techno-economic modeling. So if you look at the global market for e-fuel and specifically for hydrogen, what we are expecting that the clean hydrogen production is going to actually ramp up to 180 million tons by 2030. So conservatively, if you assume that 20% of that hydrogen is going to come from electrolysis, and having the number, the efficiency of 1 gigawatt electricity, or the installed capacity of electrolysis is going to produce around 0.16 million ton of hydrogen. So then you need around like 225 gigawatt of electrolysis installed capacity with like 550 gigawatt renewable electricity capacity installed with 50% reliability. So if you look at the actually size of all these projects, we are expecting that to have around like 300 and 500 projects globally needs to be realized in order to basically meet that demand. Right now, we have around more than 500 projects under the development, and the FID rate of the success FID rate is less than 5%. It's very low, but people are going to get smarter, and then we are expecting that this number is going to grow. But even if you assume that the FID success rate is around 20%, the number of the projects needs to be developed in order to get that capacity of 500 plants is going to be enormous. So there are a lot of projects that needs to be done. All these projects are, if they are kind of realized, they are multi-$100 million projects. So if you take like a 1 or 2% of the kind of the total cost for the development cost, still it's a lot of money you need to spend to do the pre-feasibility study, feed study before you get to FID. So what's the solution? The problem here is that all the projects are complicated, and the decision making is difficult because there are a lot of the complexity of the whole infrastructure, and also it's difficult basically to strike the balance between the technical and economic parameters of designing the plan. So definitely we need the tools, and that tool is going to be an optimization tool, because the number of the variables that we have is more than the number of the equation we can actually define for the entire system. So we are dealing with an optimization problem. And COWI has developed these optimization tools. Basically, from the left-hand side, the renewables, you get some input for the model, and also you get some constraints of the entire value chain, like the storage, the electrolysis, the methanol synthesis, distillation, and you put into the model, and you define the cost function or the objective function as the levelized cost of the final product, and you optimize everything based on that. So it receives around 20 different parameters and constraints into the model, and use the kind of optimization engine to find the minimum cost or the levelized cost of final product. So obviously that's a good measure actually to say that if your plan or the configuration is good or not. So what's the use of this? Basically, with minimum costs, you can screen or pre-screen different scenarios and configuration before you get into the feed or pre-feed study and spending money over there. So here's an example of the output of the program. On the right-hand side, you can see the capacity, how the solar basically renewable electricity production is which is shown in the green shade light area. It's kind of covering the gap that you have in wind renewable production, and it basically optimizing this capacity for the electrolyzer, and also it optimizing the curtailment or the revenue you're going to get from the additional electricity. On the left-hand side, you are also seeing that how the actually model optimizes the storage. It gives them basically the dynamic of the storage for the feed, like the CO2, and the final product, which is here in this case is the methanol. And based on this basically variation, based on the hourly basis and information that you get, and the dynamic you have over there, basically you can kind of optimize the storage facilities. So in a high level, what we can say, that's the site selection, no issues that we have once, and also the numbers that you have for the transmission, transportation, those are the input to the model and also can be the constraint to the model. Specific footprints as an input of the units, specific CAPEX, OPEX for different units, electrolysis, synthesis, even the pipeline as the input to the model. And eventually you get a kind of optimized model and configuration of the whole system, value chain, and the levelized cost of e-fuel. And also the good thing is that it gives you the kind of breakdown of the levelized cost of fuel, and by doing that, you can see basically where in the value chain the biggest contribution on the levelized cost is occurring, and you can basically work on the optimizing that part. So all in all, I said the reality of the green, if I want to conclude, that's that the projects are multi-million dollar projects. They are complex, multiple technologies involved, and the transient dynamic operation is also a challenge, but it needs to be a kind of reality, also normal operation. There are many projects going to be executed, and definitely we need a tool to pre-screen different scenarios in each project, and COWI has the tools to offer you. Thank you. If there's any question, I would be happy to answer.
Thank you very much to all four of you. And now, thanks to the speaker before us who finished early, we actually have time for a few questions. So we'd like to open the floor to you if you have any questions for our four speakers. Maybe while you think, I can just ask one question to COWI. The software and the tool you mentioned, is that available to customers?
No, it's a software tools basically developed in the company, and basically we do the project with that. It's not the kind of software that we can sell it, or it's not that kind of software. It's just we use it internally, but we do the project pre-screening of the projects.
Okay, thank you. I'll keep. Please just raise your hands if any questions arise. But then it gives me the opportunity to ask some more questions for Eva from Rambøll. You mentioned a project in Sweden, but are you only operating in Scandinavia or also globally?
We have a lot of projects going on in the Nordics, Denmark, Sweden, Norway, Finland, but also coming up a lot of activities in Germany, in UK and US, not least. We are global in the way that we have colleagues all over, and not always energy, but also from environmental and health that can do the permitting work. And it's so important for us to have that local experience combined with the global expertise on the electrolyzers and power source technologies. So yeah, we are doing it most places. Yeah.
That's good to know at this World Hydrogen Summit. I wrote another question down while you were speaking. This one is for Helge from Danfoss. How do you see the trend within electrolysis and hydrogen is at the moment?
Yeah, we believe in scale, we believe in modularization, and also in order to get the production volume up and down, up in order to get the cost down. And also what I highlighted in my presentation is that we need to build things on standard components, standard available products which can be produced in big numbers. So everybody can build something handmade and very unique, but if we want to get the cost down, as some of the speakers has been talking about, we really need to get the production volume up and base it on something that can be produced in big numbers, high quality, low cost. So I think that's my take on that. Yeah.
That's good to hear from someone with 30 years of experience in the industry.
Thank you.
I see a hand. Great.
Hello. I'm Bruno Dowd from Royal Haskoning. A question for Hassan. I do think there's a real opportunity there.
I cannot hear you, sorry.
Is this any better?
Yes.
Can you hear me now? Okay. My name is Bruno Dowd from Royal Haskoning. My question for Hassan is, I do see that there's a really big opportunity there in connecting the supply chain and optimizing it to bring down the levelized cost of energy. But what I found with our clients is that the screening you do today, the priorities change tomorrow. How does your tool and software allow clients to grow through their decision-making process?
Well, that's a good question. Of course, no, you can put a lot of constraint to the program, right? And one of them is related, for example, to certification of the fuel, RED II or RIA requirements that you have in North America. Those are the requirements that you can define to the program as the constraint and then meet them. I mean, obviously, if the requirement changes in the few years, of course, no, the model is not going to be valid anymore, so you have to change. But the best you can do, whatever constraints you have, from the technical point of view, economical point of view, and also the regulations point of view, you can insert into the model and get them kind of optimized configurations. That's best we can do.
Great. I hope that answered your question. Another question from the audience? Otherwise, it gives me the opportunity to ask all four of you a question with a final one for Ørsted. What, Sandor, do you see as some of the challenges to move the projects you represented forward to the next level?
Yeah. I think there are a couple of common themes for the program of projects that we're trying to develop across Western Europe and America. And I think a couple of ones which are different, I think, to other projects in other industries is one, we're dependent on a lot of new regulation that still needs to be put in place either by the European Commission or local governments, because this industry is still new and immature, both for us as developers, but also for the governments in place. They're putting in place regulation which needs to have a degree of maturity in order to have the assurances and the sound business cases in order for us to ultimately take the investment decisions. So that's certainly one key element that is happening as we speak, but it's not quite where we need it to be. I think a second important element, of course, is because this is a new industry and to some extent we're competing with other forms of hydrogen, be it grey, which is of course a traditional product, blue and green. The reality is that green hydrogen is still more expensive than the other colors of hydrogen, so to speak. And therefore, these projects are heavily reliant on subsidy funding, either through the European Commission or in the case of the Netherlands, through the Dutch authorities. And other countries have similar projects in other countries have similar challenges. And I think lastly, specifically for projects in the Netherlands, one of the challenges the Netherlands has is that we have a huge nitrogen emission problem. And of course, these nitrogen emissions are created through production of industrial facilities. What we're now also seeing is that construction activities, which used to be exempt from permitting regulations, are now also required to meet certain nitrogen deposition requirements. And that is causing a huge problems to move forward with these projects during the construction phase. And what we're advocating for is that in this particular case, given that ultimately these projects will significantly limit nitrogen production compared to other industrial projects, that regulation is put in place to allow these projects to move forward despite the fact and the recognition that during construction there will be some nitrogen emissions associated with that. That, as we go forward in the operations phase, that compensation effect takes place, which would really unlock some of the construction and construction of these projects going forward, which we see as a big challenge at the moment.
Yeah. Thank you. Eva, for a final comment.
Yeah, well, you said you could ask all of us the same question for Ørsted. So what does it take to see the next projects coming to, going further? We need basically to lower uncertainty, to have clarity of the frameworks, the taxation, the infrastructure, any subsidies. And the markets are, as you mentioned, immature. So we need to have that clarity. And we are pushing, everybody's pushing politicians to help us getting the knowledge, having the decisions, what rules, what standardizations across continents, because what is low carbon fuel in Europe might not be the same as low carbon fuel in America. So we need these standards and clarity.
Very good point. Maybe if we take one, one question from the audience before.
Hi, pleased to meet you. I'm Brian from Pan-Asia, Europe. And I have a question for all of you, if you can answer the questions. Because since this kind of summit is held in Rotterdam, we cannot get away from the shipping industry. So when it comes to green hydrogen, is there anybody who is sitting out there has some sort of connection or business in terms of the shipping sector, whether you can supply some of the the services or infra?
Yeah.
So that's a question. Yeah. Any project you can just highlight, that would be great. Thank you.
I couldn't hear the question.
Please, if we start from Hassan.
Yeah, I mean, we cannot, I mean, most of these projects are confidential. We cannot, disclose names of projects. But definitely it's a big business. These e-fuels, green fuels are an important part of the marine industry. And know that for the transient period, e-methanol or green biomethanol is going to be the fuel, clean fuel, and then it's going to be transferred to ammonia in the next decades. And there are engine companies are working there, but we're also working very closely with the project developers and also the shipping company in order to develop the project's e-fuel production facilities for their purposes.
Yes, just to repeat, I hope I heard it correctly. The sound is not great up here, sorry. If you know of hydrogen projects in shipping, I think that was a question.
Yeah.
If anyone would like to add a comment.
Yeah, maybe I can say a few words about that. Again, some of the projects are still confidential, but it is, of course, true that a lot of the P2X projects that are being developed at the moment, they not only produce the renewable hydrogen, but with that renewable hydrogen, there is an intent to produce green methanol, green ammonia, and those kinds of projects, and especially the green methanol and the green ammonia, they, of course, are especially suited to support decarbonization of the shipping industry. And we're seeing more and more interest of large shipping companies take an interest in that. And as that industry matures, along with the supply of these renewable fuels such as methanol and ammonia, I think we will, in the next 5-10 years, see a significant step change in decarbonization, if you will, also of the shipping industry.
Thank you.
Yeah.
Eva, quickly.
It's not a secret that a main off-taker of green methanol is Maersk and their container shipping.
Yeah.
So that's a direct connection to some of these methanol projects that you see. We do have projects with the ports. 2 of them were nominated for future ports. So kick-starting shipping, green shipping in the Baltic Sea is a project we are doing with the island of Bornholm in Denmark. And there's a lot of activities going on. I'd be happy to continue that discussion with you.
Thank you very much. We should probably stick to the time schedule, so I'd just like to thank you for your attention. After we've been demiked, we will go back to the Pavilion of Denmark, and we hope you will follow us there and continue the good discussion. We are here for the rest of the day. Thank you very much.
Thank you.